Okay, hello, welcome back. So today I will show you how to design an inductor. Just for disclaimer, this is not a real method on how to do a inductor. So this is just a simplified version. Okay, actually designing a inductor, especially for the SMPS or switch mode power supply, is quite difficult. Okay, but for this case, we just simplify everything. Okay, we just focus on the very main part. Sometimes it's work, sometimes it's not. Okay, so for this, you can use toroid or ETD, anything. Okay, so for this, I just give you example on ETD for calculation, but it's the same for toroid also. Okay, so for example here ETD, so you look for the what you call the AL. Okay, when you go here, you will try to find the AL. Okay, let me search for it first. Okay, I download the datasheet, and you can see here. Here is the AL. Okay, so AL for this case is in nano Henry. Okay, so and this is the grade. Okay, you have to look at the grade for this. I think it is 3C90. This is the material grade. Okay, and this is for the without air gap. Okay, if you have air gap, it should be different. So for this case is 3000. Okay, with plus minus 25%. Okay, so when you do calculation, of course you have to plus minus 25%. It's not perfect for this. Okay, so how to calculate it? So you can see here is 3000 nano Henry or 3 milli Henry. So I prefer to use Henry, so I convert this into milli. So go back here. Okay, unfortunately my pen doesn't work. Okay, so it worked. Okay, so the AL is 3 milli Henry. Say from this. Okay, 3C90. This one is expensive. I suggest you just buy the 3C90, much more cheaper. Okay, and then the formula is actually L equals to AL and squared. Okay, so because you want to know how many winding you need, so you just N equals to AL divided by L. Okay, sorry, wrong. So L divided by AL square root. Okay, so for example you want 1 milli Henry, so L is 1 milli Henry. So this is what you want, and sorry, this one is micro Henry. Okay, so you have to convert this into micro first. So 1000 micro Henry. Make sure the unit is the same. Okay, if not you will get the wrong calculation. So square root of 1000 divided by 3. Okay, so you get around, okay, let me calculate this. So you get 18.25. Okay, or basically 19. Okay, so you have to check whether 19 turn is enough for this. Okay, for this toroid. Okay, usually I just not do the correction, just try and error, just do the winding. If you want to do the calculation, it's quite complicated. So for this, like I said before, this is the simplified version of the design. Okay, so let's have a look here. So 90 turns, although this is only 90 turns, okay, make sure you prepare more. Okay, like I said before, there are plus minus 25%, and then sometimes the core is not too this one. Okay, it's not, the air gap is not too tight. Okay, sometimes it really reduce. Okay, you need more winding, usually very much more higher. Okay, if 19, maybe 25 you have to prepare. Okay, this is just a suggestion, because after this you will use as LCR meter. Okay, LCR meter. So you just check the winding directly, the inductance. Okay, so we continue with the hardware after this. So you need to go to P7 and level 2. You can see there is a power electronic lab here. Okay. Okay, you can go to the lab and ask Puan Nina for the winding wire, okay, enamel wire, and this one is the polyethylene tape. Okay, don't use the normal tape. This one is special tape, 30 to 40 ringgit. Okay, so this one is 0.6 mm. It can withstand around around 1.8 ampere. Okay, but don't use 1.8. I suggest just set it to 1.5. Okay, so if you need to withstand 3 ampere, you have to parallel these two wire together. Okay, so you can either use toroid, okay, or ETD. So toroid is the low one, okay, ETD is the higher one, okay, the larger one. Okay, actually it's depend on the power. Okay, if your power is very high, you need to use the bigger one, okay, to store the inductance, okay, the magnetic energy. But if your energy is low, okay, this one is usually, I think 10 watt, 20 watt, it should be okay. But this one is much more higher. If you use it, if it's saturated, maybe you have to make it larger, okay. You have to buy the larger one, okay. So like I showed before, you are doing maybe small one, and maybe the current is 3 ampere. So this one, like I said before, 1.5 ampere only for 0.6 mm. Okay, so it should be 2 wire parallel to each other. So the length should be calculated, but because we are using try and error method, we just estimate. Okay, so how many is 19 winding? Okay, so you have to estimate it properly. Okay, so I think this should be enough. Okay. Okay, you just cut it. Better use plier, but I don't have plier, just use scissor. Should be okay. Okay, so 3 ampere, you should parallel it together. Okay. Okay, so how to parallel it? Basically, you just take this end to end. Okay, and then take it like this. Okay, so after that, if 3 times, you have to divide by 3 lah. So this one is 2 because 3 ampere, right? Okay, so you have to wind it up. Okay, I suggest you connect this to something very sturdy and then try to rotate it. So this, I tied it to the grill. Okay, should be okay because you have to pull it very hard. So and then start to rotate it. Okay, rotate and rotate. Okay, I will show you after it complete. Okay, so you already twist this. Okay, should be okay. This one is still loose. I suggest you twist it very tightly. Okay, this one is not very good, but this is just an example. Should be okay. So and then you have to take one of the end. Okay, you have to use sandpaper to remove the pin. Okay, this is not a conductor, this is actually a pin. Okay, after you remove the pin, then you can have the conductor. This one is not conducted, it's insulated. So either you can burn it or you can use sandpaper, or I suggest you can use a scissor and then try to remove the pin. See, there is a pin right here. Okay, you have to remove the pin. Okay, remove it and so on. Okay, so this is just example. It should be much more longer than that. Okay, and the winding should be very tight. Okay, this one is not very good. Okay, for toroid, you just put this. Okay, and then start winding. Okay, just put it and then you turn it. Okay, do the winding. Okay, one winding. Okay, two winding. Okay, for the second one, just do this. Okay, and make sure it's tight. If not tight, your inductor will has problem. It will move. Okay, so it needs to be very tight. Even the winding, the loop is very tight. So after you tie it up, okay, tight one by one, and then wind again. And after you make the winding, before this example is 19, right? So at the end, okay, maybe they'll have extra here. After you winding 19 times, extra, cut it, and then you remove the pin. Okay, so that is for the toroid. Okay, so and then you have to measure using LCR meter. So I will show you later. Okay, LCR meter. But for this one, okay, so and then you have to remove the pin. I think I already mentioned it. So this is for toroid. So how about the ETD? So ETD is much more little bit difficult. So you have to remove this first. Okay, I suggest you just use scissor. Okay, this one, just put it in this. Okay, be careful because this one is like a glass, easy to break. So be careful. Okay, and then you remove this. You have to remove the core first. Okay, same here. And you have to do the winding in the bobbin. Okay, so I remove this. Okay, so this is the bobbin. So if I do this, okay, let me remove this first. Okay, this is not very good. You can see here, it start to wind up. Basically, if you wind this, it should not come out like this. Okay, and for this, you choose one of the leg. They have many leg. You can just choose one. Okay, I suggest maybe this one. Okay, at the end. Okay, and then wind it. Okay, wind. Okay, wind and wind. Okay, for 19 times, for example. Okay, something like this. Okay, until full. Okay, make sure it's tight. When it comes to inductor, you have to do it very tight and very neat. Okay, this one is not neat. You can see this is not neat. Okay, so you wind it up, and this one also not very good. Okay, should be very neat. If this happen, you have to start everything again. Okay, this one will become a problem. Okay, it's not very good. It should be very straightforward. And then if you have a lot of winding, you need a second layer. You have to put this tape. Okay, only a one layer tape. Okay, do not make it very large because you can lose a lot of things. Okay, a lot can be a losses if you put this too much. Make sure you just insulate this and then do the second winding, and make sure the direction is the same. Okay, so that one is depending on the knot. Okay, something like this. Okay, and then after you complete, you put for one of the end. Okay, either one side or other side, depend on you. Okay, for me, I just put here. Okay, something like this. And then after complete, you remove the end. Okay, you just remove this. Okay, remove it. Remove this, and then complete. So you have reassembled back. Put this inside here, and then put the clip. Okay, put the core and put the clip. Okay. Okay, click it until click. Make sure it will not come out. Be careful, it is like a glass, easy to break. So the next one is this one. Okay, so put this. Okay, and push the other side. Make sure it clicks. Okay, this one is still not click. Okay, now it's click. So you can use the core. So here is the adjustment. Okay, so remove it. Okay, make sure you use a meter. Okay, you can use you can do the conductivity test. You check whether the insulator already be removed or not. So you just check there and check here. If it is connected, means that the conductor, the insulator already been removed. Okay. It's quite difficult here. Okay. So make sure it is very clear. This one. Okay. So that is it. How to make inductor using toroid. Where is the toroid? Okay, this is the toroid and this is the ETD. Okay, there is other things also, but the popular one for this faculty is toroid or ETD. So now we check the inductors. So this is LCR meter, basically inductor, capacitor and resistor meter. So you just turn it on. Okay. Okay, should be no problem. So let us connect these two. Okay, this port together. Okay, I have connect the terminal, so you can see here. Wait until it change to inductance. Okay. Okay. So 778 micro Henry. So before this, you can see here winding is not very good. Okay, the winding is more or less it's not very good. So you can see here the quality is very bad. Okay, I think it's not achieve 1 millihenry. So you also can check the frequency, try to find the frequency, try to choose the frequency that is near to you. Okay, 100 is too high, maybe 10 it should be okay. Okay, 10 kilohertz. Okay, so this one, and the Q is 157. If your winding is quite good, I think it's the Q is more higher, if not mistaken. Okay, so this one I think is very bad. Okay, but for your case, make sure you do it correctly. For me, I just demo it. Okay, so that's it. That is how you do an inductor. Okay, so make sure you can ask Puanina for this and this. You cannot take everything because this one is quite expensive, so you have to ask her. Okay, make sure it is enough for you. Okay, for me it's not enough. This one it should be 25, right? I target, but this one is only 10, maybe 10. Okay, I think 2 meter is around 10 winding. Okay, it's hard to basically you have to calculate properly. Okay, that's it.